All right, Tracy, floor over to you.
Okay, great. Thank you. So Alice, I will share what I did later. I actually just came in via the web instead of the actual application, and it works.
Uh,
So this demonstration was given on Wednesday to the larger NETCCN team. And so I'm repeating that demonstration as it comes through. And really, this is a demonstration of the cross-platform application model and a simulation that we ran over the month of July over 3 days to actually be able to show the transmission of data from the telemedicine providers into the cross-platform application module as it goes forward. So, this was a big team effort with the telemedicine providers and led, as the Prime, as the Geneva Foundation, as we walk through this effort. This work has been going on for about a year. There has been a lot of sausage making that has occurred around common vocabulary, common data structure. How are you going to actually implement, standards for communication between the telemedicine providers? So, the cross-platform application module was intended to enable interoperability between the NETCCN system components, and to be able to take on the role of the aggregation and the exchange of data between those different components of the system. The exchange of data, so we're going to cover the different components of the system. One is that exchange of patient data between the NETCCN components, primarily the telemedicine providers, but also that data being sent into the operations and command cell. Looking at this as an aggregation of data for post hoc analysis, the continuation of, and then continuation into the things that we've been talking about, the DIAC of looking at continuous clinical monitoring data, the remote control of medical devices, and how does this all actually come together into this C-PAM infrastructure, and how does it work together as we go forward? So at the very high level, the system architecture we have is the telemedicine providers actually operate independently of themselves. They have their own cloud environment. They handle all of the bedside and the remote capabilities of the system. They then communicate that data through a standard common interface across to the C-PAM infrastructure. And then at that time, when they do that, then the operations and command and control, which is also called NETCCN Central, which was, the work on that was done by Expression Networks, was to actually, be able to display those operational metrics of what was occurring in NETCCN as it goes forward. So, to accumulate this, we did a simulation that was performed over 3 days in July. We set up 2 simulated patient care sites. One is Tatrick Hospital, the other is MD-PMP Hospital. They were simulated. We simulated 24 patients being admitted into those hospitals, and they were provided care using the 2 different telecritical care platforms in the system. And the intent of this was not only for demonstration purposes, but for us to test the different types of encounters of the system and the information going forward. So how does this work in NETCCN? What do you do when there's a site in need? They actually make a request for support, and the operations command and control team actually receives those requests and kicks that event off as initially. And then there's work that is done during the inside the operations command dashboards to be able to create the disaster event, create the location event, create the site, pair it to the event, assign the telemedicine provider, and assign the telemedicine provider going through. So this first video, I'm actually going to show you what that process is and the steps that are to go through and do that. So they've received a request, so they go in and they, to activate or respond to an emergency event. So they're going to go in and actually activate that event. And they type in various information, what type of event it is, what is its locations, and other essentially event details and information to be able to match up and pair things. And that's stored in the NETCCN Central data databases and information, including sites and points of contact and starts and stop times. So they've successfully created an event. They're now going to go in and create a location. Some of the things that they can do in order to create a location is they actually are pulling from ASPR databases to find sites and locations. So some information gets filled in automatically. They're filling in the point of contact at that facility, what type of support's needed when we go into the next phase of this. But right now, they're just creating that site and who the point of contact is. They also fill in additional information such as the total number of beds the site has, how many are staffed, what type of beds they are, other information that would be useful for analysis of operations, during a disaster as it started up. So now they've created the site, and so now they say, oh, well, this site is involved in this event. So they go in and actually match those two together and make that association. Because there can be multiple disasters or multiple events occurring at the same time simultaneously in the system. That possibility can actually occur. And then they have a series of algorithms that run, and they actually make a recommendation of which telemedicine performer is available. There's several metrics that go into play with this of, how many doctors they have available, how many sites they currently have, what's their physicians look like to provide that support. So as you can see here, we've created the site for the C-PAM demo. We're just showing that piece of it. And so the next step of this work and the next step of this process is that, NETCCN Central creates a site identification, and they actually make a phone call to those performers or notify those performers that they have a new site that needs to be onboarded and available, and they provide them that information to link it together. The telemedicine performer then is the one who reaches out to the site, and they start to initiate the support and the onboarding that occurs on the site. This slide is a very simple slide. I don't want to underestimate what they have to do to get on board in site. This also includes credentialing, training, those sorts of things. So they go through and start to onboard the site through the telemedicine application itself. The telemedicine performer adds this new site information to their platform. They basically then go in and add the local care providers. The remote care providers are generally already in their system. That site's now responsible. This application is now responsible for the user authentication that occurs for that site, for logins, for and who's actually using the platform and the application as it goes forward. So they handle all of that as part of their solution in the system. So then the next steps is the technology is now live. The local caregivers are onboarded. The interface to C-PAM is tested. So you're always going to send some test message. They're doing training all the while this is occurring to the care providers. And then the site actually goes live. And the C-PAM transactional infrastructure is now active. So therefore now they can start sending encounters and data from their applications to be active. This during the simulation, the next step of this and the next thing we did was we actually performed consults over these 24 patients over a 3-day time frame, which is why you're getting a video, because it would be I think we collected a little over 2 hours worth of consults and data collection during the system. So we've summarized that down into this piece. So this is now inside the telemedicine application, and they're admitting patients. As the system goes through, they're creating the applications, they're typing in all the patient demographic information as they would as they're performing a telemedicine consult. And additional information is added. There's multiple types of consults that occur in the system. It could be a nursing consult, a physician consult, could be pharmacy, could be respiratory therapy. So this is the process they go through. So they're admitting the patients into their system. What is this patient demographics? What is this information? The traditional information you would see, basically the Geneva team is also now doing the same thing. They're admitting patients into the system. And they're requesting consults. They have a little bit different care model between the two of them, but the system can actually handle both of those types of care models. Um, and then they basically go in and create an encounter about that patient. This is walking through their workflow and their process for the remote provider to get the information they need about that patient to provide a consult. Um, so history notes, down below, you're actually going to see an acuity score that's calculated. Um, as the information is manually inputted into the system um, as it goes through. There's specific questions that were asked about COVID um, and uh, completing the information. They've now signed and sent the encounter for this patient. This data then is sent to C-PAM as that encounter has sent through. Um, and we're using a FHIR interface to send that encounter information to us. And we have a minimum set of data that's required that has to be sent across. We're very conscious of the fact that in an emergency situation, they may not have all of that information to fill in. So we've provided some level of mandatory fields as it goes through. So as that data is being sent between both of these care providers, the data is received by NETCCN Central and by the application dashboards as you see these patients come through that transactional data. These are completely configurable. So right now, what you're seeing is them going in and configuring the dates of the event for data collection. And you can now start to see metrics on those patients of the number of clinical encounters they have, the types of nursing encounters they're receiving. And this was collected, about halfway through the collection process. We received these metrics for the patients. And we then also they can come in and configure these dashboards. All of these levels of setting are actually also all configurable. So you can configure them for the site. And therefore now you're receiving a dashboard update, as these systems move through. This data would be sent, they're doing these polls, it could be, hourly, is what we're looking at. We're not looking at, instantaneous, but, that this data is coming through at a pretty rapid rate for, considering that early phases of NETCCN, we did this once a day. And, in current disaster situations, you may be a couple days delayed of getting this type of metric information. So then as we move through the 2 days, we completed more encounters. A total of 54 encounters were completed in the system. And so the telemedicine providers were still submitting patients, completing encounters over that 3-day time frame. As we perform multiple different types of encounters, as I said, nursing encounters, physician encounters, different types of consults. And part of this was to be able to test out that interface and the connections. And as you can see, then we were able to actually go in and look at these dashboards. And you can see that the dashboards changed over time as we went through the different pieces. So you can look at the 2 different sites, and the encounter acuity patient count, increased at certain sites as we went forward. So the last part of that is now, what is looking at that in that operations dashboard. So we had 54 encounters over the 3 days. 18 of those were administrative encounters. That's admits, discharges, is the primary sets of encounters. But 36 of those encounters between the 2 providers were clinical encounters that were simulated during this exercise for this type of simulation. As I was saying, the visualizations are configurable, so you can go in and set your um, own rules for how you want to color code these different visualizations. You also have the ability to add additional data elements or remove data elements from the flower graphics that you see. So, for example, this is the final encounter. And if we look at unique patient count, this was the settings that we had at the end of the day to be able to provide the metrics that we were looking at each one of those two sites. The other thing that this application or the dashboards and NETCCN Central is allowed to do, anyone who's admitted into this operations dashboard can receive rules, can set up rules for notification that can be sent via text or email to these different providers as they walk through the different pieces of the system. So the data flow that we enabled with this transactional API, we used a FHIR interface connection, and we normalized that across both of the telemedicine providers. And so they were basically both sending us consistent data so we could do measures and metrics and counts as it's going forward. And so the next part I'm now going to talk about is how does this all come together? How does this come together with the work of DIAC as part of C-PAM? So now from the December 17th demo, we've added in this continuous API that's being added into this piece of it looks for, and this is what we've talked about through many of these activities. So the previous slides, you saw the transactional API and the analytics API, which both are coming across in the systems. These have been done everywhere possible where standards can exist on the provider side. The analytics API, you can either query in that same FHIR API for analytics, or we have started to set up different views for different types of analytic metrics that we're calculating every 10 minutes or so in the system to be able to actually run some of those operational metrics so we can actually calculate those in the database as it's going forward. So now you see now when you add the device connectivity piece into this and this continuous API, the telemedicine providers can access this continuous API, but that data is also now being sent into that C-PAM data repository in a time synchronized way. So both sets of data can actually be used and leveraged together. So to go back a little bit, transactional data is the document you traditionally know as electronic health record data. It's patient to provider interactions. It's provider to provider communications that may occur. But it's all of the transaction of healthcare. It's labs. It's medication administration. And it may or may not include direct patient contacts, but everything that's documented about that patient. It also includes nursing assessments, clinical scores, indexes, vital signs documentation, and medication administration can all be part of that transactional data API. The continuous data piece of this is really the monitoring and therapeutic devices with no human in the loop in the collection of that data as you're going forward. So the FHIR resources we used in this MVP level C-PAM API was a patient administration. We did pull in the episode of care resource out of FHIR, which is actually in early development or evolution. So it's not actually in the formal piece of the standard because we needed to link together in episodes and encounters. The patient resource, which is the patient demographic information, we also included veterinary information into that resource. Practitioner location observation is the catch-all for almost everything else. Clinical observations, labs, that sort of thing. We added condition codes in, and then a medication request is also now available in that API. And this is how we started to put it together, because I think it's something to be noted that FHIR connection is actually just the connection for data moving between two encounters. It actually does not have an information model. And it's actually very difficult to link these two together, link multiple things together with patient resolution. So as you go through and look at this, and something the need in a disaster was for the transfer of patients, the movement of patients. So we actually had to have some form of state that needs to be added to this. So this is the first step of doing this. The other thing this actually does, and these encounters actually do, is allow us to start to link together these clinical transactional pieces of data and information with the continuous monitoring of data and the information that's going forward. So where this went, we actually deployed this to a site at the Springfield Hospital. We went through all the testing process, all the deployment process, and had data working where we were able to actually send real-time data into the OmniCure application and being able to look at those real-time vital sign measurements on their application and on their screen. And so that's actually capable of being done. And so, that's the piece. So what does that give you? Because, in this piece, we looked at vitals and information, but actually in the database and under the hood, you're starting to get actually this continuous data feed, which includes the trends of data of measurements. You're getting waveforms, you're getting ventilator settings, you're getting alarm information, all in that time synchronized together from multiple devices. That data can be actually transformed and transferred into another dashboard that will go into operations, which is running totals of ventilation time at a location, the number of active devices being used at the time. And we demonstrated this in the December 17th demo. And we not only can we look at this now at what's the real-time piece of this, but we can actually look at this over a time frame. So we're looking this over a 14-day time frame. This data set's actually from 2 beds that were operating in a system, and we looked at that over a 14-day time frame. We can also look at the amount of ventilation time per day for the past 14 days, because just telling you how many ventilators were used may not be the most accurate information, but actually how much utilization are they getting? Are they being used for 2 hours a day, or do you have patients on them in a continuous way? So the last part of this to add into this API, and this is coming from the demo that was done on December 17th, is actually the ability to remotely control those devices and starting to enable those telemedicine providers to remotely control these devices. This is far less mature than the other parts of the system, but nonetheless, it's part of these APIs and will be continued to be evolved. And so there's multiple pieces of this we're looking at. We're looking at one is the ability to provide a plugin from C-PAM for the telemedicine providers to be able to remotely control and review this data, but also just giving the ability to remotely control ventilators and infusion pumps from a distance as part of this ongoing infrastructure. And this would also enable, alarms, other applications, other decision port applications to run across this real-time infrastructure and have better communication between the bedside and that remote provider. So I think everyone is aware, we showed preliminary pieces of this demonstration. We'll be showing more of this in the November demonstration that we're doing of being able to do remote control, not only in a hospital environment and hospital setting simulated, but also in a transport setting and simulated. I think something to keep in mind of this is that this is all software. All the hardware components for this system directly at the bedside or off-the-shelf computing devices, and we can modify and manipulate those communications for whatever the environment is needed or suited to be. This is just a link if people don't know where the links are for the demonstrations. So the next steps of this are actually to provide infrastructure, to continue to build out this infrastructure to a productization level. The primary focus of what we operationalize will be the remote providers and monitoring, where hopefully remote control is coming, a little further down the pathway. We're adding the ability to add additional telemedicine providers to the system through APIs and tools is what's going to go through the next piece. We're also having the ability to interface with additional data sources to receive data and information. So right now, the short-term next step is what people have given an update today. It sounds like we're gonna have another demo too. Was to create this common user interface for this real-time medical device data for ventilators and infusion pumps, and then that common user interface to execute remote control. The rest of the C-PAM roadmap is below. We're looking at implementing a master patient index and getting that into productization, building additional tools, further maturing out this data model of merging together and how do we link together this continuous data as well as the other pieces of data. The other key piece of this is actually implementing a patient transfer portal. So that command and control can actually assign patients to different locations, help assist with patients that need to be transported across the country. This was a big challenge across all of this pandemic, was helping smaller remote hospitals be able to find bed availability for patients. The other piece would be this marketplace for algorithms and applications, so that this infrastructure can continue to evolve as the technology and the industry continues to evolve with smarter algorithms, better visualizations, and those pieces of the puzzle.